everybody! Today we are going to cover surface area and volume of spheres. This is the last 3D figure that we're going to focus on with surface area and volume. We've already covered prisms and cylinders, we've covered cones and pyramids, and now we're going to take a look at spheres. Now spheres are just a little different than our other 3D figures because spheres don't have any straight sides. Alright, so when we find surface area and volume, it's not really going to be related to the formulas that we used before. For the surface area, so first of all, a sphere is basically like a ball. You have the center of your sphere, just like how you would have the center of a circle. If you were to look above the ball, like if we didn't see any of the stuff on the inside, it would just look like a circle, right? So a sphere has a center that is exactly the same distance from every single point in your sphere. Alright, so this right here, a lot of times this is where you're gonna see your radius, or R. And then if you see a line all the way across, that's your diameter, right? Now, to find surface area of a sphere, first we're going to find the area of a circle. And remember, the area of a circle is pi r squared, or r squared times pi. And for a sphere, the surface area of a sphere, you're just going to take that area of a circle and then multiply it by 4. Alright, so surface area of a sphere is 4 r squared times pi. Alright, to find the volume of a sphere, it's going to be similar to your surface area formula, where you have 4, you have your radius, and you have your pi. Now remember, on all of our other formulas for volume, our volume ends up being units cubed, right? So here, since we're looking at volume, we're still going to have units cubed, so instead of our r being squared, our r is going to be cubed. Alright? But similar to when we found volumes of cones or pyramids, this is all going to be divided by 3. Alright, so there's our formula for volume of a sphere. Since this is all we're focusing on today, this is what we need. Here's the formulas we need. So now we're going to put it to practice on some examples, and then you guys can put it to practice on your assignment. Alright, so here is our first example that I'm going to draw out. So to draw a sphere, just draw a circle. And it doesn't have to be perfect, because my drawings are definitely not perfect. Then you draw a little curve coming across this way, and then a dotted curve on the other side, and you've got your sphere. Then you can put a dot right in the center, and there's the center of your circle. Alright, so our first example here, I'm gonna say that this right here is 18 centimeters. Alright, can you guys see that okay? Can't answer me, but I'm gonna assume that you guys can see that okay. Alright, so we're gonna find surface area and volume of this sphere. Let's start with surface area. Alright, remember that surface area is 4 times your radius. I'm going to put parentheses here for our radius, squared, and then pi. Alright, what is our radius? Well, we can see right here the center to a point on our sphere is 18 centimeters. So I plug 18 in place of my r, and now all I need to do is simplify this out. So this is 18 squared is 324, and we've got our pi. 4 times 324 is 1,296 pi. There's our final answer, and then we would label it as centimeters squared, just like that. And then if we wanted to approximate it, plug in 3.14 for pi. This would be approximately, and I'm just going to write real quick, remember, pi is 3.14. So I'm just taking 1,296 times 3.14, or times pi. If you use pi in your calculator, you're going to get a little bit of a different answer than 3.14, so I'll show you guys real quick. Okay, so here I'm plugging in pi, just 1,296 and pi next to it, and I get a more exact answer, even though I still have to round, so 4,071.5. If I took 1,296 times 3.14, my answer would be just a little off, and that's because we are approximating an approximate answer. Alright, so, but either one of these answers I will accept. Alright, so I'm going to go ahead and use the more exact approximation. So this is approximately 4,071.5 centimeters squared. There we go. If we wanted to find volume, I say if, when we find volume, we're going to use this formula right here. So our formula for volume, we've got a 4, and then we're going to multiply by our radius, and then cube it, and then divide all that by 3. Alright, so remember our radius was 18. So now we are going to work this out. So we have our 18 cubed is 5,832. And then we've got our pi. And we divide all this by 3. So 4 times that 5,832. Big number, we got 23,328 pi divided by 3. So now we're going to divide this big number by 3. And we get 7,776 pi. No fraction, which is pretty awesome. If you do have a fraction, that's okay. Just leave it in fraction form, as simplified as you can get it. Alright? And then we would label this. This is centimeters cubed. Since we had to cube our radius, volume is cubed. And then if we approximated it, 7776 times pi is approximately 24,429.02, so it would just be 0.0, but I still put that 0.0 to show that I approximated. This wasn't exact, and there's more decimals that come after that. Alright, so there we go, surface area and volume of a sphere. We're going to do a couple more examples just to get the hang of it, make sure we're good to go. Alright, so I'm going to draw another example down here. maybe my circle will be a little bit better. Oh, nope, just messed up. Shouldn't have said anything. Alright, there's my wonky circle. Or not circle, well, it is a circle right now, and I'm making it a sphere. Alright. So, there's my sphere. And we are going to say that this distance is 52 feet. 52 feet. Alright? So, same idea, only are we given the radius this time? No, we are given the diameter. Alright? If the diameter can you guys see that? Whoop. Equals 52, then that means our radius is going to equal what? Half of 52, which is 26. Alright, so that's what we're going to be plugging into our formulas, is that 26. Okay, so same idea. Maybe I should use some different colors. We're going to have 4 radius squared and pi. Alright, remember our radius is what we're plugging into our formula here, is 26, not the 52. So, 26 squared is 676. Alright, so now we're going to multiply by 4 and get 2,704 pi. Then we would just label this feet squared. And to approximate it, plug in 3.14 or pi, and you get approximately 8,494.9 feet squared. Alright? To find our volume, remember, same idea, we've got 4, I'm going to leave a space here for our radius cubed pi, and then that's all divided by 3. Okay, so we are plugging 26 is our radius, not 52. 52 is all the way across. So 26 is our radius. And 26 cubed is another big number. You are going to get some big numbers here, guys, so don't be afraid of that. We get 17,576. Then we've got our pi. We're going to divide this by 3. Alright? So, now I'm going to take that big 17,576 and multiply it by 4. And I get 70,304. Then we've got our pi divided by 3. So divide this by 3. And here we are going to get a decimal. So we can leave it as a decimal. Because if we put it as, just to show you my work here on my calculator, I've got an old calculator, but here's what I've got. And we get this decimal, right? If I put this in fraction form, if I press math and then make it a fraction, this is the most simplified fraction we can get since my calculator couldn't do it for me. Alright, so that's the most simplified we can get. So we could leave it like this and say this is feet cubed. We can approximate it with pi since we got a decimal that kept going as to 23,434.667 pi feet cubed. And then if we plug in pi, take this big number, and we get 73,622.2 feet cubed. Alright? So, if you get a decimal when you divide by 3, that's okay. Don't freak out. Alright? I'm going to show you one more example where we work this where we work a formula backwards, and then you guys should be good to go. Alright? So, working a formula backwards, let's say we've got this problem. The volume of a sphere is 2,304 pi cubic meters. Alright? What is the radius of this sphere? What is the radius of the sphere? Alright, and we're going to round this. We should get something that's pretty darn close to a whole number if it's not already a whole number. So we're going to round this to the nearest whole number no matter what we get. Alright, so we don't necessarily need a picture here. What we need is the formula. They tell us that we know the volume. Alright, remember, volume of a sphere was our 4r cubed pi divided by 3. Alright, and here they tell us the volume, so the V is right here, 2,304 pi. So, what I'm going to do is I'm going to plug that into my formula here, so we know that that V is 2,304 pi, and then this is our formula for volume, so I'll put my formula for volume on the other side. So 4r cubed pi divided by 3. Alright, and what I want to do is I want to know the radius. So I'm going to be solving for r. I want to get r all by itself. So remember, when we're solving, if we've got everything in a fraction, the first thing that we want to do is get rid of this fraction. Okay? So, what I'm going to do is I'm going to multiply by 3 on both sides. Whoop, didn't give myself very much space there. Alright, so when I multiply by 3, I'm not going to plug pi into my calculator. Right now, I'm just going to act like pi is an x, and I'm not going to plug it in with my other numbers. So I'm only taking 3 times 2,304. I'm not going to include pi in this calculation right now. Alright, so that leaves us with 6,912 pi. Alright, and then on the other side, we now no longer have a fraction, so it's just 4r cubed and pi. Alright, now there's a couple different things that we could do next. What I'm going to show you first is I'm going to show you that typically we would divide by something, right? And you're exactly right. We are going to divide. I'm going to divide by pi first, because if I divide by pi, this is going to cancel out, right? Well, what I do to one side, I have to do to the other. So I divide by pi. Do you guys see anything that can cancel? Yeah. So that makes our life a lot easier by being able to cancel out those pi's. All right? So now what we have is 6,912, no pi, just that, equals 4r cubed. All right? So now what we're going to do is divide by 4 on both sides. Okay, so 6,912 divided by 4 is going to give us 1,728, and it's equal to r cubed. Alright, now do you guys know what to do? If we have r squared, how would we get rid of a square? We would square root it, right? Well, since this is r cubed, that means we need to take the cubed root in order to get rid of that cube. Alright? And what that cubed root means is it's the same number multiplied by itself 3 times to equal 1,728. So, here's how you can plug this into a calculator to find your answer here. Or you could guess and check if you don't have a graphing calculator, and I'll show you how to do that here in just a sec. So I'm going to plug in these cubed roots, and the cubed cancel each other out. So all we have left here is r. Alright? If you have a graphing calculator, the way that you would plug this in is you would not use your square root button, because your square root button won't give you the option of a number, an index in front of your square root. It can only take the square root, it won't take the cubed root. So to find the cubed root, you're going to go to your math button, because we're doing math. Alright, and if you scroll down, you'll see here, for my calculator, it's number 4. There's a little 3 in front of our square root sign. And so that'll allow me to take the cubed root of any number. So I'm going to click on that, and I want to take the cubed root of 1,728. And I get exactly 12. Alright, if you don't have a graphing calculator, you can guess and check by thinking, okay, this is a pretty big number, right? So let's say I want to do to check, I'll start with the number like 7. If I did 7 to the 3rd power, I would only get 343. So I've still got a lot of ground to cover. So maybe I skip a couple numbers and do like 10 to the 3rd, since I'm looking for that cube, right? Okay, so now I'm getting closer, but not quite there yet. 11 cubed, getting closer. 12 cubed is the 1,728. So that's how I know that 12 is my radius, okay? So, to answer this question, we would say the radius of the sphere is 12, what was our label? Meters. Alright, and there you have it. I'll see you guys next time. Let me know if you have any questions.